Now, a real-time framework would be used by a emulator software. And the way that this works is the emulator software will accept a query, and that emulated system will be processing the query to produce a result. Now, emulators are about operating in real time and responding to the world around them in real time. So they must actually replicate the device behavior that they're trying to model. So in the real world, devices have a latency of processing, so the emulator must also replicate that processing. So to replicate this real world latency, the emulator needs to be operating against a real world clock. And that clock would be the operating system's clock that's used on the compute platform. Now, there's a couple limitations that come into play once we're using a real-world time tracking device or a clock on the operating system. And the first thing being that the time resolution of the system is actually going to be bound by the time resolution of this clock. We cannot resolve time any better than what the system clock provides us with. Second, the amount of time we have to produce our result from our query is actually going to be constrained by our constraint of real-time operation. This means we only have a certain amount of time to produce a result given a query. This will be dictated by the type of device that we're trying to emulate or the type of interface that we're emulating. However, it does create challenges in producing data at the desired rate. Now, the advantage of having a real-world or real-time clock is that this enables us to integrate with real-world devices more seamlessly because everything is operating against the same time, which is just the time tracking that we use in standard compute infrastructure. Now, virtual time, on the other hand, is totally independent of the real-world clock or wall clock time. Virtual time is tracked within the simulation framework as another property of the simulated system. So this is very useful because it has no relation to the outside world. This means that a simulation can simulate both very, very short timescales that go well below our timekeeping resolution, or we can also simulate on timescales that go much longer than the amount of time that we would like to wait for results. There's no correlation between the virtual timeline and the real world timeline that we experience. Now, the limitations of this virtual timeline is that it doesn't make it easy to do anything in real time because really the simulated system's totally unaware of the real world time. It computes, its latency only has to do with the compute processing that is going on and not anything to do with the actual timekeeping within the system. Now, the strengths, of course, are that we can do very, very short timescales or very, very long timescales without affecting the compute time. However, there are some trade-offs.